Welcome to the Vector Academy. Let's look into the introduction to linear algebra. This section is divided into 4 parts. They are: linear algebra, numerical linear algebra, linear algebra and statistics, applications of linear algebra. Linear algebra. Linear algebra is a field of mathematics that is universally agreed to be a prerequisite to a deeper understanding of machine learning. Matrices and vectors. The nuts, bolts, tools and notations taken from linear algebra are practical for machine learning practitioners. Linear algebra is the mathematics of data. Matrices and vectors. The nuts, bolts, tools and notations taken from linear algebra are the language of data. Linear algebra is about linear combinations on vectors and matrices to form new vectors and matrices. That is, using arithmetic on columns of numbers called vectors, and arrays of numbers called matrices, to create new columns and arrays of numbers. Linear algebra is the study of lines, planes, vector spaces, and mappings that are required for linear transforms. In the 1800s, linear algebra was initially formalized to find unknowns in systems of linear equations. A linear equation is just a series of terms and mathematical operations where some terms are unknown. For example, y equals 4x plus 1. Equations like this are linear in that they describe a line on a two-dimensional graph. The line comes from plugging in different values into the unknown x to find out what the equation or model does to the value of y. For example, when x equals 0, we get y equals 1. When x equals 1, we get y equals 5. When x equals 2, we get y equals 9. When x equals minus 1, we get y equals minus 3. When x equals minus 2, we get y equals minus 7. The graph looks something like this. A straight line. We can line up a system of equations with the same form with two or more unknowns. For example, y equals 0.1x1 plus 0.4x2, y equals 0.3x1 plus 0.9x2, y equals 0.2x1 plus 0.3x2. The column of y values can be taken as a column vector of outputs from the equation. That is y equals y1, y2, y3. The two columns of integer values are the data columns, and can be taken as a matrix A with values 0.1, 0.4, 0.3, 0.9, 0.2, 0.3. The two unknown values x1 and x2 can be taken as the coefficients of the equation and together form a vector of unknowns b to be solved. We can write this compactly using linear algebra notation as y equals a dot b. Challenges in solving linear algebra problems. Sometimes there are more unknowns than there are equations to solve. There is often no single line that can satisfy all of the equations without error. Systems describing problems we are often interested in, such as a linear regression, can have an infinite number of solutions. This gives a small taste of the very core of linear algebra that interests us as machine learning practitioners. Much of the rest of the operations are about making this problem and problems like it easier to understand and solve. Numerical linear algebra. The application of linear algebra in computers is often called numerical linear algebra. Numerical linear algebra is really applied linear algebra. It is more than just the implementation of linear algebra operations in code libraries. It also includes the careful handling of the problems of applied mathematics, such as working with the limited floating point precision of digital computers. Computers are good at performing linear algebra calculations. Much of the dependence on graphical processing units by modern machine learning methods such as deep learning is because of their ability to compute linear algebra operations fast. Efficient implementations of vector and matrix operations were originally implemented in the Fortran programming language in the 1970s and 1980s, and a lot of code, or code ported from those implementations, underlies much of the linear algebra performed using modern programming languages, such as Python. Popular open-source numerical linear algebra libraries. Linear algebra package. Basic linear algebra subprograms. Automatically tuned linear algebra software. Often, when you are calculating linear algebra operations directly or indirectly via higher-order algorithms, your code is very likely dipping down to use one of these, or similar linear algebra libraries. The name of one or more of these underlying libraries may be familiar to you if you have installed or compiled any of Python's numerical libraries such as SciPy and NumPy. Linear algebra and statistics. Linear algebra is a valuable tool in other branches of mathematics, especially statistics. Usually students studying statistics are expected to have seen at least one semester of linear algebra, or applied algebra, at the undergraduate level. The impact of linear algebra is important to consider, given the foundational relationship both fields have with the field of applied machine learning. Some clear fingerprints of linear algebra on statistics and statistical methods include use of vector and matrix notation, especially with multivariate statistics. Solutions to least squares and weighted least squares, such as for linear regression. Estimates of mean and variance of data matrices. The covariance matrix that plays a key role in multinomial Gaussian distributions. Principal component analysis for data reduction that draws many of these elements together. As you can see, modern statistics and data analysis, at least as far as the interests of a machine learning practitioner are concerned, depend on the understanding and tools of linear algebra. Applications of linear algebra. As linear algebra is the mathematics of data, the tools of linear algebra are used in many domains. Specific mathematical tools rooted in linear algebra are matrices in engineering, such as a line of springs. Graphs and networks, such as analyzing networks. Markov matrices, population, and economics, such as population growth. Linear programming, the simplex optimization method. Fourier series. Linear algebra for functions, used widely in signal processing. Linear algebra for statistics and probability, such as least squares for regression. Computer graphics, such as the various translation, rescaling and rotation of images. Thanks for your time. Please like it and share it in your circle. Subscribe to our channel, The Vector Academy, for more videos, lectures and tutorials. For more information, do visit our website www.thevectoracademy.org.